Up until this point, when we're talking about compounds, we've been looking at qualitative aspects of compounds. Now we're going to look at quantitative aspects. Specifically, we're going to be looking at what's called percent composition. So how much of a compound, what percent does each element make up? So there are two different ways of doing this. If I give you the mass of each element, then you can calculate the percent composition. All you do is use the masses that are given. So you would put the element's mass that you are interested in on top, and then the total mass of the compound on bottom. So in this example problem, it says, what is the percent composition of copper in a penny if there are 1.6 grams of zinc and 0.90 grams of copper? Well, I want to know the percent composition that is copper, so I am going to put 0.90 grams on top. And then I need to know the total mass of the penny because that would go on bottom. So I need to take 1.6 and add 0.90 grams to that, and that would give me 2.5 grams. Then I'm going to find the percent. Now keep in mind, when I divide, I'm going to get a decimal, and what you have to do to find the percent, you just have to multiply by 100. So I don't actually show that, but it's implied. I get 36%. Keep in mind that's because I want two significant figures. This question is asking you to calculate the percent composition of carbon in glucose. So the first thing that you need to do, since I'm not given directly the mass of carbon that is in glucose, I need to write the chemical formula for glucose. So the chemical formula for glucose is C6H12O6. And what I did in the previous problem, when I'm given the mass, is in my formula, I put the mass of the element that I'm interested in up top, and then the total mass of the entire substance on bottom. Now in this case, the substance I'm interested in is glucose. So what I need to do is calculate the molar mass of glucose, and I need to put that on bottom. What I need to put up top is the total mass that carbon contributes in this compound. So let's first determine that. In order to calculate that, I need to find the molar mass that carbon contributes. Now, carbon has an average atomic mass of 12.01 grams per mole. However, there are 6 carbons, so I'm going to multiply that by 6. And what I get is 72.06. And I'm just going to write this as grams per mole. It can be AMU or grams per mole. I'm going to put grams per mole. So that goes up top because that is the molar mass that carbon contributes to this compound. Now what I need to now calculate is the total molar mass, which is the average atomic mass that carbon contributes, that hydrogen contributes, and that oxygen contributes. I'm actually going to write this out. You can just calculate this on your calculator. You don't need to write it out. And this is probably going to be the only time that I ever do write it out. So I know that the mass that carbon contributes is 72.06 grams per mole. Hydrogen has an average atomic mass of 1.008. But there are 12 of them, which means I need to multiply 12 by 1.008, and I get 12.096. And then to that, I'm going to add the mass that oxygen contributes, which is 16 grams per mole, but there are 6 oxygen atoms, so it's going to contribute a total of 96.00 grams per mole. So the total molar mass of glucose is 180.156 grams per mole. So I'm going to put this molar mass of glucose on bottom. And now I'm going to divide. Remember, since it's a percent, you need to take what you get once you divide and multiply it by 100. And what I got when I divided was 0.399986, so it would be 39.998. I need 4 significant figures because this has 4 sig figs. So I'm going to write this is the unrounded value. I actually need to round this value, so it's actually going to end up being 40.00%. So carbon makes up 40.00% of the total glucose molecule. In first year chemistry, you should have learned how to convert between units such as grams and either atoms or molecules or formula units into moles. I'm going to take this time right now to review that just to make sure we're on the same page. So if I'm given moles, I can convert into mass in grams. That conversion, the conversion factor that's required for that conversion, is the molar mass, and I calculate that by adding the average atomic masses of all the atoms that make up either the molecule or just simply the atom. I can also convert into particles. Now keep in mind there are three different types of particles that I could be converting into. I can be converting into atoms, I can be converting into molecules, and remember molecules are only used for molecular compounds, not ionic compounds. And finally, I can convert into formula units. Now, formula units are the units for ionic compounds because ionic compounds do not exist as individual compounds like molecular compounds do, and instead they exist as crystal lattice structures with a number of positive ions surrounded by negative ions. The conversion that enables you to convert between moles and particles is Avogadro's number, which is 6.02 times 10 to the 23rd. The other unit that I can convert into is liters. The measurement is volume. So I can convert from moles to volume. Now, that relationship is that there are 22.4 liters for every 1 mole. However, that is only the case if you are at standard temperature and pressure, which is 0 degrees Celsius and 1 atmosphere. So let's now complete an example problem to make sure we understand how to convert between different units. In this example, I need to convert 0.5 moles of glucose into grams. And so I start with my given, which is 0.5 moles. And in order to convert it into grams, I need to put the unit moles on bottom and the unit grams up top. Now, the conversion factor between grams and moles is the molar mass. So the molar mass of glucose needs to go up above in front of grams. And so the molar mass of glucose is 180.156, that goes in front of grams, and then 1 mole goes on bottom. And so what I end up with my answer is 90 grams. Now I end up with 90 grams. I rounded that because 0.5 only has one significant figure. So that's my final answer.